Hi everyone, we're going to look at how to factor a trinomial in this video that has an a that is not 1. So what that means is for any trinomial that's written in standard form, it looks like this. So ax squared plus bx plus c. So the first number in front of the x squared is the a, the number in front of the x is the b, the constant by itself is the c. So if a equals 1, then it looks like one of these examples, like x squared minus 1x, let's see, plus 6, for example. Actually, let's make it a minus 6. So we know how to factor things like this. We look for what multiplies to c and adds to b. So here's our c, here's our b. We look for two numbers that go here that multiply to negative 6 that would add to a negative 1, which is where we would get a negative 3 and a plus 2. Because negative 3 times 2 is negative 6. Negative 3 plus 2 is negative 1. So that's how we factor it if a equals 1. Because the number in front of x squared here would really be a 1. But when we don't have an a equals 1, it's a little bit trickier. We call these a tricky trinomial because there's more than one option in order to get the leading x squared thing. Like for x squared in this case, only one way to get an x squared here. It's x times x. Whereas over here we have a 6x squared, so we have more than one option. You could do 6x times x, or you could do 3x times 2x. And things get much more complicated besides that if your number is even bigger or has more factors, say for example 24x. You'd have lots of combinations that could work. And you could guess and check your way to the answer, but you actually don't need to. There is a process that works every single time, including with if a equals 1. So if you like this process a lot, you can use it for the easier examples as well. So here's how it works. Let me just get rid of this. So instead of looking at the c number, we're actually going to make a new number to look at to multiply to. So our a is 6, our b is 5, and our c is negative 4. So we're going to first do a times c. I want you to multiply the a number times the c. So in this case, it's 6 times negative 4, which is negative 24. Okay, so like how we did with trinomials where a is 1, but a little bit different here, we're looking to see what multiplies to this number instead. Not just what multiplies to c, but what multiplies to a times c, but still adds to b. So we need two factors that multiply to negative 24, but they add to a positive 5, because that's our b value. So you can go through the list of options. You could do 1 and 24, of course one of them being negative since our product is negative. That's not going to add to 5, either way you do it. 2 and 12, again, either one would be negative, still not going to add to 5. 3 and 8, though, seems promising. If I use 3 and 8 and make one of them negative, I'm going to get to a positive 5. And the trick is to make the 3 a negative. Because negative 3 plus 8 adds to our 5, which is the b. Okay, so we're going to use those two. And we're going to use those two numbers as the way we split up the value of b, which is kind of weird here. We're not going to look at those as like x minus 3 and x plus 8 that we did for when a is 1. It's not going to work out like that. But it is going to be helpful to us to actually factor this. And here's how it works. We're going to take the 5x and we're actually going to split it up into two pieces. We're going to keep this 6x squared the same, but we're going to call this minus 3x plus 8x minus 4. So all we've done so far is rewritten 5x as negative 3x plus 8x. And as you can double check, if you add those two back together, you'll get back to 5x. So we didn't really change the problem yet, or we're not going to change the value of the problem. We're just rewriting it in a more useful form. Now, the big question I usually get with this is, does it matter the order of these two pieces? Could we do it as 6x squared plus 8x minus 3x minus 4? And the short answer is no, it does not matter the order. In fact, I'm going to hold on to this, put it over there, and show you in a little bit that you could do it either way. Let's start with this way. So what we're going to do next is we're going to actually cut this in half. So we're going to split those two pieces there into two separate little factoring problems. And we're going to find the GCF of both of these parts. So for 6x squared minus 3x, we're going to factor out that GCF, which is 3x. So we're going to put that first. And then we're going to figure out the inside. Well, 3x taken out of that would be 2x minus 1. And then for the other part here, factoring out the GCF of those would be a plus 2. I'm sorry, not 2, 4. Let's try again here. 4 times 2x minus 1. And I knew it wasn't 2 because if you try and do 2 here, you get 4x minus 2. So I said 2 at first, but that actually wasn't the greatest common factor. And here's how you can tell. These two have to match. If they don't match, we've got to make a match. We've got to be kind of creative sometimes. Like say, for example, we did, instead of using a 4, we used a negative 4, which is possible. You might want to use that in some cases. If we did a negative 4, then it would be a negative 2x plus 1. But then these two wouldn't match. So sometimes what you have to do is actually make the symbol work so that they do match. So make it a positive 4 in this case, such that it'll be the exact same factor, 2x minus 1, in the parentheses. And now what happens here is the 3x and the plus 4, that becomes one of our factors. And the other factor is the 2x minus 1. Because what's essentially been done here is we're undoing the distributive property. This 2x minus 1 was distributed into the 4 and into the 3x and written like this. So we're just going backwards and saying, well, this is the same thing. I can take this whole thing, multiply it to the 4, multiply it to the 3x, then you go back a step. But we want to get it in factored form written like this. And that's how we factor a trinomial that has an a that is not 1. And this process, again, works if you change the b around, or it works if a is 1 too. So you can always use this process instead of guessing numbers. You can always jump right to this procedure. So let me just double check over here with this example. I said it works either way, so I better show you that it does. So what is the GCF of 6x squared and 8x? Well, they're both even. They both have an x, so let's do 2x. And then it would be 3x plus 4. And then over here, let's see, well, I want to get a 3x plus 4 in these parentheses. I'm going to put it there. We want these two to match, otherwise it's not going to work out. So how do we make that work? Well, let's take out a negative 1, which is obviously totally fine to do. And now if we combine these two into a factor, 2x minus 1, and the other one, 3x plus 4, you'll see this is actually the exact same answer, just written in a different order. And we know that the order doesn't matter for multiplication, so either way is totally correct. Let's look at just one more example down here. So oftentimes what you can do first is make the numbers a little bit easier to work with. If I try and do this a times c first, I'm going to have a pretty large number to work with, which is just harder to find numbers for factors. So if I first find the GCF, it'll make my numbers a lot smaller, which again will be easier to work with. So what is the GCF of 8, 20, and 12? Well, let's call that 4. Looks like 4 would go into all of those. So let's use a GCF of 4 first in order to simplify our tricky trinomial, this a equals not equal to 1 trinomial, and make it smaller numbers. So then that'd be 2x squared plus 5x plus 3. I'm going to zoom in here. Okay, so now what we're going to do is we're going to kind of ignore that 4 for now, because really it's not going to help us factor the rest of this. We're going to factor the inside part as if it was its own problem. So this is the new a, b, and c. So then a times c would be 2 times 3, which is 6. So we got to find two factors of 6 that add up to 5. So that would be 2 and 3. It's actually the same ones we already have. So we're going to use, because those two add to 5. So we're going to rewrite this as 2x squared plus 2x plus 3x plus 3. Inside those parentheses still, and the 4 is technically still there. It's technically still there. So all we've done is we've taken 5x, called it 2x plus 3x. Okay, now again, we're going to cut this in half. We're going to do GCF of each part. I'm going to put a big bracket here with the 4 out front, so I don't forget about that. So 2x would be the GCF times x plus 1. And then for the GCF of 3x plus 3, that would actually just be 3 times x plus 1. And then 2x plus 3 makes one factor. The other factor is x plus 1. And there really is that 4 still out front. I kind of Wrote it kind of weird here with the brackets. But really the 4 is times the whole thing, like this. So now we are factored, and we are factored completely. 4 times 2x plus 3 times x plus 1. You can tell it's factored completely because there's no other GCFs we can take out here. 2x plus 3 doesn't have any GCF, and neither does x plus 1. So that's how we factor it. Again,